the leaf, and after that, if there is any kind of soap present, then it can detect early, before the agriculture or before the cropping or farming of the farmers. The main focus of our literature survey mainly focuses on the topics of early detection, deep learning, computer vision, CNN models, data collection, and model development, because many surveys were previously done on our topic, and those were mainly breached into early detection, because to classify the tomato illness for early disease detection, then using the deep learning, because deep learning provides an innovative image processing method for effective predictions in agriculture, then coming with the computer vision to identify plant illness using real time data, and then for CNN models and the hybrid methods to diagnose tomato plant illness, and then data collection. And further study includes model development. These are some of the studies which we have consulted for our research purpose. For instance, Agarwal et al. Developed an 8-layered convolutional network architecture to identify illness in tomato crops, while some other research used a simplified CNN model where researchers classified 9 tomato crop illness in plant village dataset. Then some other researchers also used GANs or generative adversarial networks, which is a very hot topic in the field of Gen AI, which used unsupervised image translation to enhance the learning. Then some of the other researches also include various other pre-trained models like VGG nets, mobile nets, Inception V3 and all, coming with the and ending with K means neural networks, use the back propagation neural network classifier and clustering segmentation to extract about 24 color, texture, and area variables from leaf samples. Our problem definition includes that tomato leaf blight detection can be benefited, can be impactful, and can be research oriented and challengeful in several ways. This research can be benefited for timely intervention, reliable identification, scalable solution, and efficient detection, while it is impactful due to economic stability, reduces yield, and dark lesions means to detect the any kind of patch or spots on the leaves of various plants or trees. Then, what is actually aiming is that CNN model implementation, deep learning techniques, automatic disease detection, early intervention, and management too. And the challenges that can be mainly faced while doing this research is human error while collecting the data sets. Maybe it cannot be much scalable, then visual inspection, time consuming, and labor intensive. Now, this is a complete flow chart of our proposed work, which started from the data collection and pre-processing using the plant village dataset. We have extracted a data of around 11,000 for our training, testing, and validation purpose. Upon that, after pre-processing and all, we have selected the pre-built models like ResNet 9, DenseNet, RCNN exception, and one modified CNN model to train the dataset which we have collected. And again, we have modified the CNN which we had collected. And then we have evaluated using the evaluation matrices of accuracy, F1 score, sensitivity, and specificity. While implementation, we have classified the images into this based on their diseases, and then field testing validation, and our research work can be used for automatic disease detection system in the real world purpose. Coming to the methodology and implementation, one notable thing I want to share is that we have used deep sharp to correctly identify if there are any kind of specific spots and to actually detect the differences between each kind of spots of each individual disease types. Deep sharp is a very notable part in our project. And for the stages of our proposed model, we have pre-trained all the data sets which we have collected. Then we have fine-tuned based on the classes which we have taken, then disease classification, then symptoms detection and visualization based upon the lesions. Coming to the results and discussion, as I had mentioned that we have used several pre-trained models like DenseNet, Exception, ResNet 9, RCN, and CNN model. These are some of the scores which were provided by the different pre-defined model upon our training. And what we can see is that the proposed CNN model, which we have modified, it gives the best accuracy among all, giving it as 92.27% as an average accuracy. And upon the prediction dataset, it gives an average accuracy of 94.37%. This is the confusion matrix of our proposed CNN model, which can be used for misclass if there are
Anansha,
kind of
Anansha,
any
enough.
misclassification. Okay.
So you have gone through some literature survey, right?
Yes.
Yeah. What are all the common drawbacks you have identified from that?
Some of the drawbacks which I have identified is that there are several issues with the pre-trained model. Like some of the pre-trained models, while I had also used the Google Net or mobile net, which I had derived from the other papers, but it was not giving that much good accuracy at as it was mentioned in the previous papers. So I need to switch in between several other models, and I need to refer to other papers. So yeah, as per it is mentioned in research papers, like it is giving the best accuracy, but the information somewhat are not reliable. We need to check it with our own model, with our own data set, to verify if the model is actually giving reliable accuracy or not.
So you are telling modified CNN in your flowchart, right?
uh, yes,
Whether it
modified
is
CNN.
integrating with any other models,
Pardon, I couldn't get you.
you have used the modified CNN, right?
I
For the
Yes.
proposed model, you have named it as a modified CNN.
Hmm.
Yeah, whether it is integrating with any other models.
No, we haven't integrated
No,
with
no, no.
it with
Just a
any
minute,
other
sir.
models.
Some flavor of ResNet and VGNet was also in the layered architecture. It was incorporated. Sorry to interfere, Anangsha. That was
Yes, sir.
also,
Tell sir.
yeah. That was also part.
Hmm.
We have taken some features of ResNet and VGNet. So that was
Yes.
there. So we actually started with Anangsha started the work in the first year. So she's a AIML student, and the basic idea was to find out that which model works best. So the studies started with the entire data set, and this data set used, I think, 11,123. Anangsha can actually tell me. So that's
Yes.
after pre-processing. Yeah.
11,000.
Yeah,
So
moreover, in that confusion matrix, you have given commonly, I think there are some four models are there in that, right?
yes, yes,
We
yes,
utilized all the four types
Hmm.
for performance measures.
yes, yes, yes,
You have utilized all four measures.
yes, yes. So the entire code was redone, and maybe there are also advancement in the existing models like ResNet. They're modifying VGNet, DenseNet. They're modifying. Even GAN is also working. But in our study, we have used the modification. Anangsha, if you can share that PDF
No, sir, I am
format.
asking about that confusion matrix. In this slide,
Hmm.
you didn't mention what measures you have taken at in that four types. Whether you have checked with all the four types.
Yes, yes, it is checked with all the four types.
Yes, we have checked with all the four types, and
Come
this is
to
the best
yeah.
confusion
No,
matrix
no, no.
we which have derived using
Come to
the
the paper
CNN
now. You
model.
can show that all the confusion metrics, also the results with the accuracy and loss. Come to the next slide. You can also
I
show.
guess we
Yeah,
can do that.
yeah.
These are some of the laws and techniques, and these are the other confusion matrix. Like this is the confusion matrix of ResNet 9, and these are some of the confusion matrix of other studies, VGG 19, which was done by other researchers. There were several other confusion matrices also, but these two were the best ones, so we used it in our paper.
Yeah, okay, ma'am. Ma'am, it's over from my end, ma'am. Thank you.
Okay, sir. Okay, thank you, ma'am.
Thank you, ma'am. We are leaving. Thank you. Bye.
Next paper ID 1213.